choices you can think of. Have like, you know.
Well, it depends what coins you use. If you make up new coins, it's totally fine.
Can I use a doubloon?
Can you use a what? A doubloon? Are they legal in America? No. Some Krugerrand. I know some of you guys are still going. I just want to collect some data. I want to collect some data real quick. If you're still going, we'll just add your data in. We'll add your data as we go. So let's go to the first question. How many draws does it take until you see a repeat? Now, does everybody understand that the least number that's going to take is 2? Because you could go like diamonds, or hearts, or blah, blah, blah. How about the max number it could possibly take?
5.
Very nice. How come? Because?
We got one.
Well, because you got one of them. Good. How do you mean you can't go any further?
Yeah, 4 suits.
Because there are 4 suits in the deck. Worst case scenario, I call this worst case scenario because Ian was saying, man, I wish I had some of those worst case scenarios in the second question. Worst case scenario for a repeat is you get one of each suit in the first 4 draws. Whatever comes out next has to do what? It has to match one of the 4 that you already got. So all the data for the first one is going to be 2, 3, 4, or 5, yes? So let's go around the room, raise hands if you got 2, and with fingers show me how many of those you got. With fingers show me how many of those you got. I imagine there's a few. Alright, let your hands go. I'm sorry, this is for question number 1, my friends. It's question number 1. Yeah, question number 1. If you're looking for 2 on question number 2, you won't find it. Alright, so we have 2, 4, 8, 12, 13, 14, 15, 19, 22. That's 4, Whitney?
Yeah.
26, awesome. 28, 37, 43, 46, 49. Excellent. I'm going to make a prediction right now.
There's going to be a lot more 3s.
I predict we're going to have about 200 to 220 total. I'm going to throw a number out there. I think this is going to sum to about 2 to 220. I'll explain momentarily. This is my guess based on mathematics. Okay, 3. How many of us took 3?
1.
3, 3, 3, 3. So this is 3. Good. Some of us need 2 hands at this point. Need 2 hands at this point. Good. Good. 2 hands. So for 3, we got 3, 6. 11, 18, 23, 26, 28, 30, 6, 38, 41, 47, 48, 53, 58, plus 5 is 63. 63, thank you, friends. Yes, ma'am.
We have one in there. Part of this one. Do you want my numbers?
Whatever you got, sure. So 1 more for 2, 4 more for 2. I'm going to leave my guess at roughly the same as it was.
No, now you just. And I actually had 5.
So 4 more, 53. And then say again.
And then I had 5.
In that right here. That should be 68.
Yeah.
Okay, excellent. And now we haven't gotten a 4 yet. So. 4s took us 4 till we saw a repeat. Took us 4 till we saw a repeat now. 3, 7, 8, 13, 14, 17, 24, 27, 38, 41, 43, 46. All right? And last but not least, 5. It took us 5 to see a repeat. It took us 5. We saw all 4 suits, and then the 5th card that came out, we just had to flip the 5th card. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16. Oh, I saw it. And took 20 altogether. 20 altogether. All right, I was off by a smidge. 187 total, which means I still can't count. You guys got some more?
No.
So I'm just trying to get the raw data. So essentially, what we just did was we collected this data on page 2 of your quiz. There's a little chart to fill out right there.
Yeah.
Just drop that data in. So the question came up is, I guessed, based on this number, that there was going to be about 200 total. It's 187, it's a little bit lower, which meant 53 was a little bit high probabilistically. Why would I have guessed, probabilistically, why would I have guessed that the total would have been about 4 times what this is? Anybody have a theory as to why I would have guessed the total would have been 4 times the first number? Any idea? Michelle, what were you thinking back there? You had an idea.
Because there's 4 suits.
There's 4 suits, and here's the deal. whatever card you throw down first, right? Whatever card you throw down first, what's the chance the next card matches that one? 1 out of 4, or 25%. So 25% of the time, you should have been done after 2. It doesn't matter what you throw first. What matters is what you throw second, and if it matches the first card. So if you throw clubs first, you throw clubs second 25% of the time. If you throw spades first, you throw spades second. So 25% of the time, your second throw matches your first throw. So my thought was, this should be about 25% of the total. So I multiplied it by 4 to get to 100% and called it 200. It's a little bit low, which means you guys were a little bit high, but that's data. But I got a ballpark, you see. I knew it wasn't going to be 600. And I knew it wasn't going to be 32. So I had an idea. Michelle, go ahead.
Well, I was curious why you just automatically knew there was going to be more 3s.
Oh, because it is 25%. The other 75% have to be spread throughout the remainders. See, so 25% of the time, this has to happen. That means the other 75%, this has to happen. In other words, it's too hard to get a match in the first 2. It's going to be easier to get a match in the first 3, or a repeat in the first 3. It just has to. I mean, if it's too hard to happen originally, it has to happen somewhere down the road. And I assumed that the data was going to kind of go like that, like it did like that.
Why wouldn't it be 4?
Why wouldn't it? I'm not saying it wouldn't be 4. I'm saying on average, what will it be? You're asking the questions that my son asks me, and how I answer questions with him is we collect data and look at it. It's a great, and then you look for patterns. And we're going to extend this with the dice with your TI program. It's a great question. Why wouldn't it be 4? You're taking Math 243, right? Because we totally answer all these questions with a lot more detail than Math 243. Oh, it's a fantastic question. Yeah, why not 4? Why not? Why is it 3 and not 4? We'll get into that, I promise. And 245 does it even with even more detail. So that's why that's a great course. Let's do the average, shall we? Let's do the average. Notice I don't have it up here. Because on your quiz, I think one of the point values for the quiz is what is the average number of times it takes until we see a repeat with 4. So can we do this weighted average last time by hand? Last time by hand. Yeah, I think we can. We've got to do 2 times 53, yeah? Plus 3 times 68. Plus 4 times 46. Plus 5 times 20. All over 187. And I'm almost positive that's supposed to be 200 just because I can't count. It's supposed to be something that ends in a 0, if you think about it, right? Because if each of you did 20 trials, or 10 trials, should have a 0 on the end. So
Yeah.
I'm guessing I can't count. So doesn't surprise me at all. All right, let's crunch it. Let's just do it with you guys. I'm sorry. Do it with my head. Well, it looks like I'm going to give you guys a pretty fun way of approximating averages too, based on graphs. When you think of an average and you have a graph like this, think of that as a tray, and you're a waiter or a waitress trying to serve by carrying that tray. What would the average be? Where do you have to put your hand to balance the tray? Well, define middle though. Is that the middle?
The middle of the weight.
Thank you. The middle of the weight of the tray. If all these bars were the same height, this goes back to your guys' question we just answered. If all these bars were the same height, then 3.5 would be the average, because that's the perfect middle because the weights are balanced. But do you see how there's more weight on this side than there is on that side? There's more. Imagine these are stacks of cookies or something like that. Stack of cookies, stack of cookies, stack of cookies, stack of cookies. Well, if you put your hand here, what's going to happen to the tray? It's going to tip this side, right? If you put it too far here, it's going to tip that side. So where's the average? It's going to be somewhere in here-ish, yes? So now the question is, how far-ish? If you need more precision, that's why you have to go to the calculation. Does everybody follow that logic? If all you need is a ballpark, like this comes up at a meeting sometime when you're at work, and they're looking at that, oh, on average, what's the salary? On average, what's the expenditure? Well, it's a little bit below in here. It's a little bit somewhere in the 3s. Does that make sense? It's somewhere low, maybe high 3s, but it's definitely closer to 3 than it is to 4. So Kelly, what do you got back there?
What?
I see you shaking your head. No, never mind. I'm sorry to pick on your brother. I saw you shaking. Brittany, go! 3.17.
I totally had such a good guess. I said either 3.1 or 3.2.
And that's a perfect average now, isn't it? 3.1 to 3.2. What do you have? 3.1 to 3.2. Kelly, what's on your mind?
Nothing, absolutely.
Absolutely nothing, okay.
Stop messing with me.
I'm sorry, I'm reading your face wrong. It seems like...
Where you live.
Damn, you hear that, YouTube world? So, the idea is, the average has to be this way of the data because of the weight. I love the way you say it's where the weight is balanced. It's where the weight is balanced. So if we said, Michelle, remember we said, if the bars were all equally sized, the average would be directly between 3 and 4, which would be 3.5.
Okay, so if they were all.
If they were all the same height, if it was this.
Wouldn't it be 2?
No, careful, careful. Where would you have to put your hand to balance that tray?
Closer to.
Right here.
Okay.
Which is directly between 3 and 4, which is 3.5. But they're not all equally sized. There's a little more weight on this side than that side. And that's why the average is closer to 3.2 than 3.5. So if you need more precision, you can do the calculation. If you just need a ballpark, it's a little bit south of 3.5. Kelly, go ahead.
Now I got a question.
Go.
Wouldn't it be 2.5 and not 3.5 because there's only 5?
Because it's only, well, because it starts at 2 though. It doesn't start at 1. The lowest data point is 2. Correct, of course, if your data point started at 0 or 1 or something lower, but it starts at 2. So you've got 1 data point, 2 data points, 3 data points, 4 data points would be directly in the middle of the middle 2, which would be 3.5. Great question, great question. Cool. We now have an answer for how long it takes us on average until we draw a repeat, 3.2. We're getting closer to Max's question and the whole point of doing this. Not that I'm making you do my homework for you, but I mean, we're getting close. And now, the big one. Keep dealing until you see all of the suits, yeah? So let's go to the next screen.